Welcome to Future Forward, where we explore the technologies actively building our tomorrow. I'm Alex Ryder.
And I'm Ben Carter. Today we're talking about a crisis that's, well, it's largely invisible, but costs our cities billions of dollars and trillions of gallons of water every single year. We're talking about leaks.
It's a staggering thought, Ben. I mean, in many cities, up to half of all the clean treated water pumped from a plant, it never reaches a single home.
Wow.
It just seeps away through countless tiny cracks in this, aging underground maze of pipes. But what if that network could talk? What if it could not only tell us where it's broken, but maybe even begin to heal itself?
That's not a hypothetical anymore. We've been digging into a system called Nexus Water, and it's a fundamental leap forward. Now, as an engineer, I tend to be skeptical of buzzwords, but this is different. It's a full-stack solution, and it all starts with the ability to listen. So, Alex, let's talk about the sensors. They call it a quantum acoustic array. Break that down for us.
Of course. So, for decades, the best practice has been to use acoustic sensors, essentially, very sensitive microphones to listen for a leak, but that's incredibly difficult in a noisy city. The Nexus system uses quantum-enhanced sensors. Think of it this way. A normal sensor is like trying to hear someone whisper across a busy restaurant.
Okay.
A quantum sensor, it's like having a pair of headphones that can perfectly isolate that one whisper and filter out all the other noise. It gives them the ability to hear the unique acoustic signature of a leak as small as 0.1 millimeters.
The width of a human hair. And those are the leaks that are the real silent killers for a utility, right? They don't cause a spectacular geyser.
Exactly.
They go unfound for years, just constantly wasting water and slowly eroding the ground under our roads. But look, having a great microphone is useless if you don't understand what it's hearing. This is where the AI, what they call the smart twill engine, becomes the real star of the show.
Yes, exactly. The AI is the master interpreter. It's been trained on a massive library of sounds from water pipes. It knows the sonic difference between, say, a pinhole leak in a PVC pipe and a larger crack in an old cast iron main. It can distinguish the hiss of escaping water from the hum of nearby electrical lines. So within 60 seconds of that quantum sensor detecting a faint anomaly, the AI can say with 95% confidence,
Wow.
This is a leak. It's right here, and this is how serious it is.
That speed and accuracy are transformative, but the real aha moment for me was understanding how this data feeds the system's digital twin. It's a term we hear a lot, but this is one of the most compelling applications I've seen. How would you describe it, Alex?
So the digital twin, it's a perfect living, breathing, virtual replica of the entire city water network all on a screen. Every single pipe, valve, pump, it's all represented. And because it's fed real-time data from thousands of these smart sensors, it's not just a static map.
Right.
It's a dynamic health chart for the city's water arteries.
And it's not just for monitoring, it's for predicting. You can ask it questions. We have a new housing development coming online here. What happens if we increase water pressure to that zone? In the past, that was, well, educated guesswork. Now the digital twin can run a simulation and come back with an answer. It'll say something like, warning, increasing pressure by 10% has a 78% probability of causing a stress fracture in this 90-year-old pipe segment 3 miles away.
Yeah.
It turns infrastructure management from a reactive guessing game into a predictive science.
That's a massive step. But the Nexus vision goes even further, right, into the realm of full autonomy. Ben, tell us about the hardware that actually works inside the pipes, the pipe bot swarm.
Okay, this is where it gets really exciting. These are small, autonomous, almost fish-like robots designed to live permanently within the water mains. They don't just inspect, they patrol. And using swarm intelligence, they work collaboratively. So if one bot detects a minor internal corrosion spot, it can call over others in the swarm to get a more detailed multi-angle analysis. And they build a 3D map of the flaw from the inside out.
So instead of even waiting for a leak to happen, you have a 24/7 internal security team just ensuring the integrity of the network.
This opens the door to what they call no-dig repair, which is the ultimate goal for any city, and that complements the most futuristic part of this whole system, which is this concept of a self-healing infrastructure.
It sounds like biology, not engineering. The idea is that the pipes are constructed with or lined by these advanced biomimetic materials. When a micro crack forms, the material itself reacts to the presence of water and chemicals to precipitate minerals,
Wow.
effectively sealing the crack automatically. It's like the clotting mechanism in our own blood.
Okay, let's walk through the whole sequence then. So, a microfracture begins to form deep underground. Instantly, the self-healing material in the pipe begins its work. At the same time, the quantum acoustic array detects that faint energy release, and the AI flags it. The system then automatically dispatches a nearby pipe bot to perform a visual confirmation from inside the pipe.
Right.
A human operator sitting in a control room just gets a simple alert that says, "Alert! Minor fissure detected at Sector 7 Gamma. Self-repair initiated. Internal inspection confirms seal is forming. No action required."
That's the future. An infrastructure that isn't just smart, but resilient and autonomous.
It certainly is, and it leaves us with a fascinating question for our listeners to ponder.
So, here's a question we'd like you to think about. As our critical infrastructure for water, power, transport becomes truly intelligent and autonomous, what is the new role of human oversight? If a system can predict and fix its own problems, where do we draw the line between trusting the machine and retaining human control?